All right, our next unit of study is simple harmonic motion. What we're going to be focusing on in this video is just period and frequency, that alone. All right, so you hopefully have learned about circular motion. There's a deep connection between circular motion and uniform circular motion. So any of those concepts that you learned from circular motion will apply to simple harmonic motion. Simple harmonic motion can be thought of just as a one-dimensional projection of uniform circular motion. If you were spinning something around in a circle, obviously that looks like circular motion. If you were to stand on end and view that, you would see that object going up and down. So you're creating a one-dimensional view of that circular motion, which is simple harmonic motion. Here's our first equation. Period, the whole notion of period. We use a capital T, an uppercase T, for period. So this is period. Its unit, and this is unfortunate, its units are seconds, and we use the lowercase s for the units for period. Periods are measured in time, they're measured in seconds, and the big equation is period equals time, and time, unfortunately, we also measure with units seconds over n, and n stands for the number of rotations or the number of cycles. So the number of times this thing goes up and down, up and down, up and down, or around in a circle, that's the cycle. So this is our big equation. Period equals time over the number of cycles. Our first equation, our first problem, if it takes 50 seconds, so our time is 50 seconds. For an object to travel around a circle 5 times, well, that's n. That's the number of rotations, and n has no units, by the way. It's just the number of cycles. What is the period of motion? So we're looking for period. That's our unknown, and our answer is going to have the units seconds as well, because periods has a unit seconds. If you do the problem, you should come up with period equals time over n, 50 seconds over 5, and the period is 10 seconds. So B would be our choice. Now we have a problem where an object's traveling in circular motion and its period is equal to 7 seconds. How long? So we're looking, how long will it take? We're looking for time. That's the unknown. To make 8 complete revolutions, that's the number of revolutions. So we use our equation, period equals time over n, but we're solving for time this time, so we have to multiply both sides by n to isolate the time. So we're going to get time equals period times n. And when you plug in your numbers, you should get 56 seconds. So now you should be a period expert at this point. Now we're moving on to our next our next concept, which is frequency. Frequency. The number of revolutions that an object completes in a given amount of time is frequency. All right, so frequency, we use lowercase f for frequency. The reason we don't use uppercase f is we use that back in dynamics for force. So we don't want to use uppercase f, we want to use lowercase f. Its unit are hertz. If you look at the tachometer in your car, when you sit behind the wheel of your car, you're going to see RPMs. That's revolutions per minute. That's actually a frequency. And we get that from looking at our frequency equation, where we have frequency, this is frequency, and that's measured in hertz, H-E-R-T-Z, commonly abbreviated Hz. That's its units, hertz, is equal to n, and we already know what n is. It's the number of cycles or the number of revolutions over t, and t is time, once again, and that's measured with unit seconds. And the reason why I said your tachometer look at your tachometer, it's revolutions per minute, right? So that's a frequency. So that's one way to remember what a frequency is, or compare it against a period that we learned just a few minutes ago. Let's move on. Our first frequency problem. An object travels around a circle 50 times. So n is going to be the number of times it's moving around a circle in 10 seconds. That's a time. What is the frequency in hertz? We're looking for frequency. So we have frequency equals n over t. Solving that problem and plugging in our values, we get an answer of 5 hertz. Next problem, if an object is traveling in circular motion with a frequency of 7 hertz, how many revolutions? So we're looking for how many revolutions, and again, there's no units for revolutions, will it make in a time of 20 seconds? So we have our equation, frequency equals the number of revolutions per unit time, and we want to solve for the number of revolutions. To isolate the number of revolutions n, we'd have to multiply both sides by t. The t's would cancel, and we have n equals time times frequency. Plugging in our values, we get an answer of 140. Now that we know about period and frequency, we know period is time over the number of revolutions or cycles, and frequency is equal to the number of cycles or revolutions over time. If you look at this, they're kind of opposites of one another. We say they're inverses of one another. Another way of saying something is an inverse is period is equal to 1 over the frequency, and frequency is equal to 1 over the period. Having that knowledge, let's take a look at a problem. An object with a period of 4 seconds, so we have a period equal to 4 seconds. What is its frequency of motion? Frequency, we're only given a period. So how do we find its frequency? Well, we know that frequency is equal to the inverse of period. So 1 over 4, and we should get 0.25 hertz. An object's revolving with a frequency equal to 8 hertz. What is its period in seconds? Well, period is going to be equal to 1 over the frequency. 1 over 8, yeah, I know the answer is not exactly 0.13, but fairly close if you do it on your calculator. And that should end our video.